All right, guys, so we're jumping into polymerization reactions, and there's two types, an addition polymerization and a condensation polymerization. In the next bunch of clips that I'm going to do, I will go through a number of examples of each so that you have a real good grasp of what they are. But just really kind of simply put, here's sort of like a very generic and simplified template of what a polymerization reaction is. And whether it's an addition or a condensation, the general idea is the same. Polymerization reactions simply are reactions that make polymers. That's why we call them a polymerization. Now, mono means one, we know that from chemistry. Poly means many, and so all a polymer is it's made out of many monomers. So here's some examples of addition polymerization reactions. A couple of things I just want to point out. These guys here are the monomers. Now in this example, this first example right here, the monomer that's being used is just a molecule of ethene. So you can see 2 carbons, 4 hydrogens, and a double bond in the middle. Sometimes ethene is referred to as ethylene, just a different name for it that is pretty common. Now, what an addition polymerization reaction is you take these monomers and you just add them together into one large molecule. But when you do that, you'll notice here that this monomer that's written in black ink and blue ink and red ink all end up in the molecule over here, and they're all attached. But one major difference that you'll notice is that these bonds here now are all single bonds, carbon single bonds. And so the way that these monomers attach to each other is that this double bond is broken, which now opens up the octet for these 2 carbons to now get another bond attached to them. And so all these double bonds are taken out, and then these carbons attach themselves here and here into one large molecule. Now, the reason for the dots here on the side is just simply to say that however many monomers we have here is going to dictate how long that polymer is going to be. So the dot just means, a continuation of however many monomers is going to be. A part of that is going to dictate how long that is. So when we name these, the monomer ethene is what's being used. When we go to the polymer and we have to name it, we're just saying that this polymer is made out of many monomers. So it's made out of many ethenes. So we call it polyethene. Now, because ethylene is kind of more the common name for this substance, then this is called polyethylene, which you may have heard of that substance before. It's just like a plastic. It's this plastic that, like, for example, the garbage bags are made out of and stuff like that. So these polymerization reactions we find are reactions that are used all the time to allow us to have certain materials that we have in our everyday life. Take a look at this second example. We've got the monomer styrene. Styrene is 2 carbons double bonded with a benzene ring coming off of one of the carbons. And you can see here that when this reaction takes place, again, the double bond comes out, and we just have single bonds here in between the carbons so that those monomers can attach to one another and not violate the octet rule. And then this monomer styrene, when you use many styrenes to make this polymer, we call it polystyrene, which is just the scientific name for styrofoam. And so that's what this substance is here. So that's an addition polymerization reaction. We're just taking monomers and we're adding them together into a larger molecule. All right, so the second type of polymerization reactions are condensation reactions. And what condensation really means is that we just have a small molecule that comes off when these monomers attach to each other. And as I showed you in the previous clip with the template reaction that was there, we have a bunch of monomers that react to make a polymer. So the monomers that exist in condensation reactions, one of them that we can use are ester linkages. And so this is a dicarboxylic acid, which would be considered a monomer, and this would be a dialcohol, which would also be considered another monomer. Di just meaning 2, so they've both got, this has got 2 COOH groups, this has got 2 OH groups here. And what happens in this chemical reaction is just an esterification reaction that we learned about in a previous video. And so the condensation that happens from this reaction is this water molecule forms, it comes off, and then those two molecules link together using the ester linkage that occurs once that happens. Now, you can see here that I've got this dicarboxylic acid written here, and this dialcohol written here and here. And so it's just in an alternating formation or path. And so this carboxylic acid end reacts with this alcohol end here in that esterification, creating that ester linkage, and simultaneously it's happening on the other side of the molecule over here with this other dicarboxylic acid molecule that's of the same type, but it's just another one that's there. And so you get these ester linkages that happen all the way down. And so if we have many ester linkages in this molecule, then we just call it a polyester. And you all have heard of what polyester is before. It's just a synthetic material that's oftentimes made in the lab, used for making clothing and things like that, or other types of wear that you might have. And so down here is the molecule that has all these ester linkages in them. And so you can see here's an ester linkage right here, and an ester linkage right here, and an ester linkage right there. That's COO group. Now, when we're writing the products for these, though, we don't write it exactly like what I've gotten written here. What I've done is I've written out each of these, showing you where the ester linkages are, but each of these molecules are intact. On the ends, though, this is really not what's happening. If you look over here, I've got this dot, dot, dot that I showed you in the previous clip. It just means I could have this alternating formation happen for X number of molecules down the chain. So however many of these I have is how long my polyester is going to be. Same thing over here on this end. And so when we're writing the products here, all we're going to do is we're just going to write out what the chunk of molecule is that contains everything that's different. And then, as you can see, it repeats as we move down the chain of the polyester. And so any of the repeat stuff that's in that molecule, we don't need to write it again. And so all we do is we identify what is the polyester that is made in this reaction, and then we stick brackets around it and say that this chunk of the molecule is what repeats again and again and again. And so if I take a look at this really carefully, I can see, okay, I've got this molecule right here that if this is, I could start here at this end, or I could start here. It doesn't matter as long as you're finding what is the chunk that contains the whole molecule. I start here on this C, and sorry, I'm going to start here on this O and go all the way down. If I go to that O right there, what you can see is this O is in the same position as this oxygen is here. And so this oxygen right here I wouldn't include in the diagram. I would take that out. This I would leave in there because that's part of the part that doesn't repeat. And then all the rest of this, I would take this out as well. And so at the very end, this is my polyester. And so I could take this chunk of this molecule, stick it on the end over here. I could take this chunk of this molecule, stick it on the end right here, and it would perfectly repeat as I had written on the board before I erased it all. So if you need to, you can go back and kind of look at what was on the board previously, so you can see how it repeats throughout the chain. But this is all that you would need to write for the products. If you were asked, here are the reactants, what is the product? This is all you would need to put down. Another type of question that you can see in this case, we've got dicarboxylic acids reacting with dialcohols. Another type of polyester that you can see is you have a molecule here that has, say, a carboxylic acid functional group over here, and a hydroxyl or an alcohol functional group over here on this side. And so you've got a molecule that has a COOH and an OH within the same molecule, and then just that molecule repeats down the chain, where you've got then this carboxylic acid in this molecule over here next to this alcohol that would then form that ester linkage on that side. And so you can see questions that give you problems like that as well. And that's all you guys need to know about condensation polymerization. Thanks for watching. We'll see you in the next one.